Hello and welcome to this video lecture for percent yield. Percent yield is a comparison of how much of a product a reaction should create to how much of the product was actually created when we physically did the reaction in the real world. By the end of this video, you should be able to calculate percent yield when you're given an actual amount that was created. The formula for percent yield is really simple. Like all percentages, it's a part divided by a whole times 100. For this specific percent, it's going to be, the part is going to be the actual, what's called the actual yield. So it's the part of the amount that was actually made. So the bottom is called the theoretical yield. And the theoretical yield is what math tells us should be created. So in a perfect world, if every mole reacted exactly like we think it should, that's the amount that should be created. And then of course, like all percentages, you probably want to times that by 100, and then you're going to get your percent yield. So it's the amount that's actually created divided by the amount you calculate should be created, and then times 100. So how much was actually made compared to how much you calculated could possibly be made. And that's really all that there is to it. Now, a few things. The amounts, the actual yield and the theoretical yield, they can be in grams or they can be in moles as long as they're both the same. So the actual yield and the theoretical yield have to be in the same unit. Anytime you do a comparison of any kind, you need the same units to compare those. So let's take a look at an example. Let's say that I'm going to make some, let's say we're going to make some salt. It's a pretty simple reaction. I'm going to take some sodium metal. We're going to add it to some chlorine gas, and we're going to make some good old sodium chloride. I'm going to balance that puppy out. Got to make sure you have a balanced equation here. So let's just see. Let's pick some numbers. Let's say that we react 100 grams of sodium, and there's an excess of chlorine. There's plenty of chlorine. That's not going to run out. And let's say that we make 52 grams of sodium chloride, and we want to know what the percent yield is. Alright, so what do we need? We need two things. We need the actual yield, which I will circle in green, and we need the theoretical yield, which I will circle in blue. So what does our problem give us? Well, it gives us one of those two yields. If you look, the product is sodium chloride, and our problem says how much is made. So we said 52 grams of sodium chloride. So that is our actual yield, because that's the problem is saying was actually made. What we don't know is the theoretical yield. We're going to have to calculate that. So the problem gave us how much of our limiting reactant we have, 100 grams. We have to calculate how many grams of sodium chloride that's going to make. And at this point, you should be getting really comfortable with a simple stoichiometry conversion like this. So we have 100 grams of sodium, and we're going to go from grams of sodium to moles of sodium. So we're going to need the molar mass in here of sodium. Let me grab the periodic table down here. Sodium, if you don't know by now, is 22.99 grams per mole. So 22.99. Okay, so we'll put that here. Oh, 20. Okay. And then mole ratio between sodium and what? Well, sodium chloride, the product that we're interested in. So sodium chloride, right? We're trying to find the percent yield of sodium chloride, so that's the one we want. So let's see, moles of sodium 2, sodium chloride 2, so this is just a 1-to-1. And then because we're in grams, and remember what I just said, it's got to be the same unit to compare. We're in grams. We're going to go from moles of sodium chloride to grams. So we're going to have to do some adding. 22.99 plus 35.45. So let me clear this out. 22.99 plus 30, oops, 35.45. All right, 58.44. So 58.44. So now that's all that's left is to do the arithmetic. So let's grab our calculator and clear out the previous number here. So 100 divided by 22.99 times 58.44. Whoa! Holy cow, 254. Let's see, we've got 3 significant figures there, so we're going to stop right there. 254 grams is what we should be looking at. So let's check it around. Yep, so 254 grams. What is that? What did we just calculate? Well, remember we needed the actual yield and the theoretical yield. The actual yield was given to us in the problem, so we just calculated the theoretical yield. So this is the theoretical yield. So how do we find, we're ready now to finally calculate percent yield. It's the actual yield divided by the theoretical yield times 100. So our actual yield is 52 grams. Our theoretical yield is 254 grams. We're going to divide those and then multiply by 100, which, you know, we can probably do in our head. So clear this out. 52 divided by 254 equals. So that's 0.2047. So we're going to multiply by 100, move the decimal 2 spots, and then I want only 2 significant figures because this is 2 significant figures. So it looks like 20% yield on this, on these numbers that were given to us here. Now a few things. Something that often messes students up with these kinds of problems is understanding how to actually divide them correctly. So let me bring the, I keep sending my calculator away. If it's 52 over 254, then 52 is what goes in the calculator first. This is 52 divided by 254. So it's 52 divided by 254. And you got to make sure you enter it right or you're not going to get the right percent yield. So that's how you calculate percent yield. There are some other things that you can do with the percent yield. If you're given the percent yield, you can calculate the actual, for example. If you are interested in that, that's something that you can research and maybe get some help with in class. But for the quiz that you have to take, I believe all you have to do is calculate percent yields, just like I showed you. So that's it for this video lecture. If you have any questions, feel free to ask in class, and thanks for watching.